Okay, ladies and gentlemen, this is going to be our practice test. Making sure that I'm actually doing the practice test. So first off, we're going to graph. Let's actually make this a little bit lower because I'm already foreseeing that we are going to move up 3. I'm sorry for the way that a lot of the text look. I don't have a way to do this on my iPad. And another software where it looks better. So this is kind of what we're going to have to deal with. And if it's really glitchy, I also apologize. But we should be able to at least power through it, or at least see what's going on. We're graphing cosecant. We're going to graph 3 sine of 1/2 x. I'm looking at this. I definitely... Oh, that's annoying. I think this should be a pi here. I don't know if that's something that's consistent, but it's going to be really hard to graph it if it's just 1. So I'm going to make this pi. I remember literally writing this question thinking about what this had to be in the middle. But anyway, so let's just make this pi. We have a few things that we're going to look at. We got amplitude, period changes, phase shift, and a vertical shift, and we're doing cosecant. So 5 things that we have to do. Let's start with our period. So that's going to be 2 pi over 1/2, which is going to equal 4 pi. Amplitude 3, amp is 3, vertical shift up 3, phase shift to the, nope. So we're dealing with positive, we're going to the left pi. Great. So let's start by graphing. This is going to be -3, we'll call this +3. We're going sine, so we're going to go up, down, back up. I'm going to cheat, copy, and paste. Look at that. Look at me go. The end point of our period is going to be 4 pi. So 2 pi, 3 pi, pi, negative pi, negative 2 pi, negative 4 pi, and negative 3 pi. Whole bunch of stuff to do. What should we do first? Let's do our phase shift first. So we're moving it over pi. So this is actually going to start to look like our graph of cosine for moving all of our critical points to the left. And then there would be another point that just pops up here. So all our points go to the left, and the left. So let's draw. So purple, we are going to have, that's our phase shift. Now we are going to, I'm going to draw, no, I'm not. We're going to do a vertical shift now. So with the vertical shift, we're just moving it up 3. We'll do it in green or something. Make our axis in black. So we're going to go up 3. So I'm going to hit the x-axis, and that is going to be our bottom. And our top is going to be at 6. Now the next thing that we have, and the last thing that we have, did the period, we did the amplitude, we did the vertical shift, we did the phase shift. Now we have to just graph cosecant. So let's start by graphing our asymptotes, and that's going to be where the purple graph hits the x-axis. So we're just going to go here. And there we go. So in orange is going to be our final final graph. Going off the green. Good. And that is what we're left with. So leave that on for a sec so we can pause it and move on with our life. Graphing cotangent. So this is cotangent of x over 2 plus 3. Let's remember that when we're doing our period, we're going to do pi over b. So that's going to be pi over 1/2. So it's going to be 2 pi. So our period is going to be 2 pi, that distance in between our asymptotes. And then we have a vertical shift of plus 3. Draw our axis. Our asymptote for cotangent is going to be on the y-axis. And then over here. And then over here. And since our period is 2 pi, we have 2 pi over here, 0, 2 pi. Let's think about where tangent is positive and negative. It's going to be positive in the first quadrant. So we start up and go down. Start up and go down. I don't know if there was a negative in either of these or if it got taken away, but if there was a negative, all you would do is flip the graph. Now let's talk about moving it up 3. We just have to make our graph go through that point. And then you're good to go. So that is that. Graph of cotangent. Arc sine. So graphing arc sine. We know that our domain and range have to change. We're going to go from negative pi over 2 to pi over 2, negative 1 to 1. So now, when we're graphing this, let me make sure I'm saying this right. Okay. When arcsine is negative 1, so we're taking the arcsine of negative 1, that angle that we're at is negative pi over 2. And then our arcsine of 1 is going to be positive pi over 2. Then we're going to draw that. And that is going to be it for our graph. We've got to make sure that a few things are correct, that our axis is correct, as well as the curvature of the graph, because those are both important points. Next, for 2 and 3, find a model for simple harmonic motion that satisfied the specified conditions. Very good. So we have displacement at equals 0 at t equals 0. So if we're going to graph this, we know that we could only use sine or cosine. If it's at 0 going up or going down, we know that this is the sine graph. So we're going to be dealing with sine. We see our amplitude is 7. Now we have our period is 3 seconds. So we know our period is calculated with 2 pi over b. Excuse me, it's 2 pi over omega. That is equal to 3. So solving, we're going to get 2 pi over 3 is equal to omega. So now we're going to get 2, 3, t. And that is it. Did the same thing down here. But note that at this time our displacement is 4. So it's going to start like that. So we're going to be using cosine. Our amplitude is 5, and our period this time is 2.5. So we're same exact thing. 2 pi over omega is equal to 2.5. So 2 pi over 2.5 is equal to omega. And I'm just going to go ahead and call this 4 over 5 t. Oh, pi t. Let's make sure we got that in there. Let's make this look a little bit nicer. 4 pi over 5 t. There we go. For the simple harmonic motion described, give the following. Our maximum displacement is just given by our amplitude. Oops. Our frequency, instead of doing 2 pi over omega, we have omega over 2 pi, where our omega is 12 pi over 2 pi. So our frequency is 6, and it doesn't give us a time, so it's just cycles per unit of time. Value in time is equal to 6. So we are going to just plug it in. If we get 1/4 cosine 12 pi t, we're going to get 1/4 cosine 72 pi t. Realize that 72 is even, so it's going to be coterminal to 2 pi. And then all we have to do, and well, let's write this as this, times 6. So we know where we're getting that 72 from. We know that our cosine at 2 pi is 1, so that value of d, that displacement, is going to be 1/4. Now we're finding the least positive value of t. Remember, when we're dealing with cosine, we have to set the inside equal to pi over 2. So now, when we get, we're going to divide by 12 times 2 times pi, so we're just going to get 1/24. And that will be that. You could also think about it, because we have cosine, it's going to be at this point. And when, oops, I hate when it does that. Cosine of x, this is what this is in general, but at this point, this is cosine of pi over 2. So we need to set the inside equal, we need to set this part equal to this part. Find the exact value of each expression. So let's go ahead and start. And this is giving me a headache looking at it. Let's lower the brightness a little bit. Sorry if that affects it on your end. I'm getting a little bit of a headache right now. Cosine of 315 is just radical 2 over 2. And now I need to find the arcsine of radical 2 over 2. So that is going to happen at these 2 points, at like 45 and then 135. But then we have to remember where sine can live. Sine can only live in these 2 quadrants. So this is just going to equal 45 degrees. Next up, tangent of 225. So tangent of 225 is going to be, that's in quadrant 3, going down here. So that's just going to be the inverse sine of 1, because you're going to get radical 2, negative radical 2 over 2 over negative radical 2 over 2. That's going to equal 1. And when is sine equal to 1, that's just going to be up here. So now we get pi over 2, or 90 degrees. tangent of 11 pi over 6. So let's make sure we're doing 11 pi over 6 correctly. 11 pi over 6, the coordinate there is radical 3 over 2, negative 1 half. So if we're going sine over cosine y over x, it's negative 1 over 2 multiplied by the reciprocal. And then we'll get negative radical 3 over 3. So now I want to know when the tangent is equal to negative radical 3 over 3. So this is going to happen at 2 times. When we have this as our coordinate, and then when we have the other version. So when we have negative radical 3 over 2, and then positive 1 half. So it's going to happen at these 2 points, and let's go ahead and draw these on the unit circle, or on a unit circle, just a little graph. So those are going to happen at like these points. Now our tangent restrictions are the same as our cosine restrictions, so it's going to have to be in those 2 quadrants. So then the tangent of, you know, this angle, or this side length, excuse me, not angle. We could rewrite this as the inverse tangent of negative radical 3 over 2. Nope, 3 over 3. And that is going to net us the same exact thing, 11 pi over 6. And then we're done. Because it has to be this one, it can't be over here. Next. Arctan. Wonderful. 3 over 5. So let's draw. Oh, I don't like this question because it doesn't work with pretty numbers. So because they're both positive, we're going to deal in this quadrant. 5 is there. Oh, no, it's not. Excuse me. Tan is opposite. This is our angle. Opposite is 3. For hypotenuse, so you're going to get 3 squared plus 5 squared is equal to h squared, or this is going to be 9 plus 25. And then you're going to get root 34, right? I believe so. Root 34. I know that doesn't look right, but we're just going to have to stick with it. Root 34 for that. Now we want the secant of it, and secant is the reciprocal of cosine. Let's just put this down here. So let's start with the cosine, and let's just call this theta. Cosine of theta is equal to the adjacent over the hypotenuse, so we're going to get 5 over radical 34. I'm not going to bother rationalizing it because I know that this secant is then just the reciprocal of this, and those rationalizing it would essentially give us more work. So that is our answer there. Let me make sure I'm right here. 9 squared, 25. Okay, for some reason I thought it would be something slightly different, but that looks good to me. And lastly, oh, not lastly, we have 2 more. So one is going to be with our angular speed and then linear speed. We have the spin balance machine thingy. Let's draw a picture. Great. We have our 30-inch diameter. Oh, I'm going to need a calculator for this. This is unfortunate. 30-inch diameter at 250 rev per minute. So we want to find the angular speed in radians per minute. So what we need to do is find what one, or how per revolution. So for 1 rev, we go 2 pi radians, or 2 pi radians per rev. So 2 pi radians per revolution. But we have, what do we have? 250 revolutions. So we're going to go 2 pi radians per revolution times 250 revolutions per minute. We're going to get 500 pi. Our revolutions are canceling out, so we're going to get 5 pi, or 500 pi radians per minute. And that's that. So we're done there. You could leave this in terms of pi, I don't mind. The linear speed in miles per hour. So stuff here is going to get a little bit funky. I haven't done this out yet, so let's make sure we're doing it right. So the first thing that I'm going to do is convert 30 inches into miles. And there's a number of ways you could do this. You could do this all in one really long formula, but let's just find our diameter. Or maybe let's do it in one really long one. Why not? Let's just go for it. So we have 30 inches. We need to convert this to feet. So 1 foot over 12 inches. That will get us to feet. And then we need to go to miles. So 1 mile over 5,280 feet. So that's going to get us our diameter in miles. Now to find the circumference, we're going to then multiply by pi. So now this is going to get us, let me make sure I'm clear here. This is so this is the diameter. I think doing it the other way is going to make a little bit more sense now that I am putting things together. Okay, let's do it the other way. Let's not do it all in one. So we're going to get some number, and this is going to be in miles. Pull out a calculator. I want to get a fraction for this so that it looks nice. So 30 times parentheses 1 divided by 12 times parentheses 1 divided by 5280. That's going to get us 1 over 2112 miles. And that's going to be the radius. So now we can start and say per revolution. So this is going to be the calculation of the or the circumference of that circle. We'll get our diameter. Think of this as a diameter. Not the diameter. No, it is the diameter. Diameter pi. So this is going to be miles per rev. Now we need to find revolutions per hour. So we just take 250 rev per minute and multiply that by 60 minutes per hour. So let's take 250 times 60. We'll get 15,000 because our minutes are going to cancel out. So 15,000 rev per hour. So now what we do is multiply this by 15,000 rev per hour. Our revolutions cancel out. So now let's multiply, and we get, I want to get pi out of here. So we're going to get, no, I don't want to be in fractions anymore. Whoops. Oh, man. We're going to get .62588 pi mph, and I want to get this in a decimal. So this is about 7.10. Nope, that's without the pi. So if we multiply our answer by pi, we get about 22.3. I'm using an eraser. 22.312 mph. All right, sorry about that. That's a little calculator troubles, but we should be good to go there. So let's take a minute and read this question. So Mr. Shell's about to take a penalty kick in a soccer match. The goal is 8 feet tall. So this is an aerial view. This is the aerial view of the soccer goal. So let's look at a side view. So if this is our ball, I would hope that most of you are at least somewhat familiar with the greatest sport on earth. And if you aren't, you need to get hip. So we could pretend that this is our goal. Here's our net. This is our goal. Okay. The goal is 8 feet tall and the penalty spot is 36 feet away. So this is 36 feet. This is 8 feet. So it says I kick the ball at a 15-degree angle of elevation, and I'm kicking the ball perpendicular to the goal line. So basically what this means, I had to include this, saying that I'm just kicking it straight. And we're just going to assume that this goalie sucks and he won't make the save. Because ideally, you want this ball hitting, you want it hitting this side net, because that makes it virtually impossible to save. But that's quite a bit more to calculate, and maybe a challenge problem for the future. But so we're going perpendicular, so it's going straight at the goal. If I kick it at a 15-degree angle, now I just want to know if it's going over or if it's going in. So basically, all we have to do is calculate what this angle is. And then if this angle is larger than what I kick it at, we're good to go. Because then you can imagine that in this red, my ball is going, over here. But if this black line, if this theta is smaller, then you can imagine that I'm skying this. Now, how we do this, go tangent -1 if theta is equal to 8 over 36. Well, it's not tangent -1, it's tangent. Opposite over adjacent, go arc tan of 8 over 36. Typing this into the calculator, 8 divided by 36, nope, not 39, 36. That is equal to 12.5288 degrees. So that means that the angle to the top is about 12.5. If I'm kicking it at 15, that means I'm somewhere up here. This is 15 degrees, and I'm skying this boy. So our answer is no. Boo, Mr. Shell. Fun fact, I've never missed a penalty kick in a soccer match in my life. What you don't know is that I've never taken one, because I played defense, and they didn't trust me. Anyway, that is our practice test. I really hope the video wasn't glitchy. That would suck. The last few have been, but hopefully this one isn't. If you have questions, let me know. Just email me. All right, have a good rest of your